All right. Um, well, let's get started. Yuri, thank you for joining me on this webinar, and thank everybody else for taking the time to find out more about shadow APIs. I think I kind of like this title, Yuri, is the find them, test them, fix what matters, right? That sounds like a reasonable objective for our AppSec engineers that we typically speak with.
Totally, totally. I mean, it's so important to find what you don't know about and make sure that you secure it.
Yeah. Yeah, I
Ideally,
think,
before it reaches the production, of course.
of course, of course. And I think that's really what we're going to try to get to the heart of how we can help, because this is a real problem in the industry. I mean, and as we'll kind of dig into it, of what's happening, and really how what level of assurance do businesses have as they're releasing APIs, right? And then how much compensating controls you have to add because they have such a low level of confidence inside of their API inventories and the resilience of the applications themselves. And so logistically, for all the people joining, once again, thank you very much. We will record this session and provide you a recording if you want to go back to it. Please ask all the questions that you want. There's a Q&A feature inside of Zoom that I'm sure everybody knows that, and we'll get to those questions at the end, or if it makes sense, we can address them right up front. But before we jump into the subject matter, one of the things was that you may not be that familiar with Invicti, and so we wanted to sort of give you a recap of what's happened at Invicti over the last 3 months, which has been an amazing time of transformation for the company, right? And one of the things that happened back in June was that we converged our two DAST platforms, Acunetics and NetSparker, the two number one, number two DAST platform in the industry. And then in July, we did an acquisition of Conducto, the one of the pioneers in application security posture management, or ASPM. And now all three of these brands are under the Invicti brand. And sort of what's notable about what does this really bring, and the innovations of being able to combine these three forces, is one, from a testing perspective wise, for DAS, for web apps and APIs, is that it's really speed. That's always been a complaint about DAS, is that it can take a long time, but the Invicti DAS is on average is in the 8x higher performance than the rest of the market. There's been some innovations that were applied inside of it, specifically around AI. And Jerry, you and the other product teams and developers have helped to really make this much stronger, being able to use AI for login assistance as well as form filling, um, to get this additional some 40% more coverage as we're getting deeper and deeper into the applications. And then, of course, there's new capabilities in addition to the AI-powered portion of it. And today's topic is sort of related to, which is the shadow AI discovery capabilities, and being able to run a suite of tests in order to ensure that the LLM implementation was done correctly. And then today we're going to really focus on this particular topic, which is a lot of advances, Jerry, that you've been sort of leading the way on API discovery, right? And then the last portion of it, obviously, is with the Conducto. And here, what we think that the value that we're bringing into this particular group is that being able to have DAST as an anchoring mechanism for ASPM, right? That gives you this ability. What security teams have always been asking us for is how do you get the runtime portion of it correlated and start being able to work it through the rest of the data, including SAS data, getting these correlations so that we can accelerate and anchor ourselves in runtime. And so very exciting products, and these combinations to make significant impacts to AppSec engineers, right? So so I guess, Yuri, let's go ahead and just jump into our topic then.
Yeah, let's do that.
So let's talk about the problem, right? The problem. Well, for sure, there's no question that APIs are taking over the internet. It depends on who you ask, which research that you go look at, and it ranges somewhere between 71 and 90% of all of the internet traffic today is API based, right? And that these growing areas, especially around the SPAs or single page applications and the API backend that sort of drives them, as well as the really rapid growth of machine to machine headless API implementations that are driving things like mobile gaming, streaming, and especially the for our primary audience of these business to business or machine to machine communication links, right? That are really sort of powering financial institutions, retail, um, health services, and whatnot. And just as we see these things, we also know that today attackers are following right along with it, right? And today, it's a dominant mechanism for attack strategies, and I guess this is sort of following in that attackers know where the weaknesses are, and APIs tend to uh, have more vulnerabilities or are less stringently tested than let's say typical web app. But probably more important is that APIs are the thing that separate the attacker from the business data that ultimately that they're going after, right? And so so this is where we want to kind of focus in on, provide some guidance on how we can solve some of these problems and make some recommendations. However, API security as a term means a lot of things depending on who you're talking to, right? And I think that there's a little confusion, and we want to be crystal clear what we're talking about, right? And specifically, we're talking about the rightmost pillar here, which is API for AppSec, right? This is discovering vulnerabilities, using security testing, and using posture management is to make this possible, right? And and of course, the other areas of such like inline protective tools such as WAPs or API gateways is one category in live networks, and then passive API monitoring, um, doing traffic analysis in order to do that, which is still a little bit related to the AppSec portion of it. But let's just be crystal clear that this is what we're talking about here. All right. So the capabilities that we're going to focus on from the Invicti side of how we can help these AppSec engineers is, one is the discovery portion of it, right? And we're going to go through what I would consider as a multi-layered approach for being able to get a complete inventory of the APIs that are driving the business, right? And that's going to be including things like what we're going to introduce you to as an idea of a sensorless API discovery, API-M or gateway, API gateway integrations. And then the third area is using traffic analysis in order to be able to discover APIs and reconstruct API specs. Then of course, as OWASP API top 10 vulnerabilities, they make up something in the order of 90% of all of the attack tactics that are um, that that companies or attackers are typically using. So this includes BOLA and BLFA, which I believe is something in the 40 something percent of the reported attacks are around them. Right? And then another category is stateful API scanning. And here, in addition, is using context from the communications that you're having with the API, is to try to reuse those parameters in order to be able to find, issues around business logic as well as just CVE types of vulnerabilities as well. Um, yeah. All right. So what's the problem, right? So, just like our little test has sort of a poetic three of the three cadence. When we talk about some of the problems around API, this first one is deployed quickly, tested loosely, and forgotten entirely, right? Right.
I wouldn't go with forgotten entirely, but I mean, it is close enough.
Yeah, yeah. But this is what's happening, right? And then the second one is even another problem. They're undocumented, misconfigured, and exposed to the internet. And that's really where the big problem comes in, right? Is this term of shadow API that's out there, and these struggles that many of the business are having of meeting their objectives, right? And you see that in the reports, especially around, with the statistics of only 12% of businesses feel confident that they have an accurate inventory of all of their APIs. And I think in our dealings with our AppSec engineers, as we bring up our systems, we see this as pretty consistent. And then really the scariest part of it is that Cloudflare introduced a report that said that um, based on their customers coming into the environment and specifying what they had when they actually did the uh, and traffic-based analysis, there was actually 31% more APIs than they had actually thought that they had, which is quite alarming. But at the same time, it seems to be um, uh, quite true, right? And so I guess
I mean,
Jerry, what's your sense as far as interacting with customers as well as being a sort of
yeah,
a
I mean, I see exactly the same stuff because most of the AppSec teams that we speak with, they either say, yeah, well, we got some spec file, maybe a host name, and that's it, right? So they have very little understanding of what the API is for, how critical it is, right? And but this is still happening in a small portion of the targets that our customers are scanning. So we see very few customers are actually doing the preventative testing upfront. Like there's a couple of very recent examples from the market because one small Brazilian dating app just recently in September was taken offline within weeks. Why? Because they had a BOLA and any user was able to fetch anyone else's profile and selfie of the ID just by changing an ID number. Imagine that. That's like a privacy one-on-one problem, right? Ended up that founders pulled the plug, wiped the database, but the risk to business is tremendous, right? We can only guess if the problem was that it wasn't properly tested or if it was documented, but the testing was done very quickly without any proper evidence. Right?
Mhm. Yeah. Hey, just
Yeah.
for our audience, if they're not that familiar with, I guess I sort of threw out these acronyms as well as BLFA and whatnot, but maybe
Yeah.
you remind the audience what BOLA stands
Yeah,
for.
for sure. I mean, BOLA is broken object level authorization issue, right? So if you go into the OWASP top 10 APIs, this is one of the, as you mentioned, on like one of the most frequently discussed problems in APIs because it essentially means that either you go vertically or horizontally within the application, which means, let's say that Don is an admin and I'm a ordinary user of the application. I shouldn't be able to access those data in any shape or form because the permissions should be properly built in into the API. But if I try it and I do that, we have a problem. Same goes to horizontal issues, right? Where let's say that Don and I work for completely different organizations, but most of today's SaaS applications are multi-tenant, which
Mhm.
means both Don's organization as well as my organization are on the same hardware on the same application. Should I be able to seize data? Of course not.
Yeah.
Right. So that's where these acronyms or these issues are becoming more and more familiar within the market and within AppSec because again, we're seeing more and more demand for testing these on known as well as unknown APIs so that AppSec can be sure that these are not present.
Yeah, and I guess that's probably like that first problem is I guess it's a sort of aphorism. You can't defend what you don't know, right? And
True. Yeah.
these stats are there's a lot of things that don't know, and probably you could even say like the whole company wise, is it true that it's really shadow? Maybe not, but from an AppSec perspective wise, it very well can be because at least they don't have the
Yeah.
stats and they don't know where they are, and some of these other tools just can't do that, right?
Yeah.
So
Yeah. Totally.
But
I mean, it reminds me of a different case. Was it May, June? There was this Ivanti breach that was basically using two types of API attacks. One was just bypassing the authentication, and the other one was just RC. I mean, that's a
mm,
significant problem because that combo gives you full access and full control to the API. So there's no passwords, just a good way to craft the HTTP request to get access to those underlying systems. Big problem.
yeah, it's every day. There's
Yeah.
a
Yeah.
report one, and it's problematic, and but ultimately
I
this is
still believe that, don't I still believe that we're only hearing about the biggest problems. I think it's happening more often than we can even imagine, to be fair.
yeah, I think so too. So 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 what we want to make sure that people understand is what is involved in this? Well, first of all, we should think about AppSec and think about what is the charter of AppSec, right? And sort of in the simplest case, it is ensure only secure apps or APIs in this instance are released to production. That seems like a pretty simple statement, but and the answer to that is how do you know that it's secure? Well, you got to test it, right? I mean, that at the end of the day, that's really the only answer. And and there's many stages that can be tested, but ultimately that last portion of it, which is where DAST comes into play, which is in the runtime environment, from the outside in, just as an attacker would do it, is really that last level to say I'm secure, right? And so how do you actually test these types of things is that there's two components that are required, and this sounds so simple, yet it's become so complicated. One, you have to know where is it, right? You have to know it exists, and you have to know where it is so that you can point at it. And then the second thing, because APRs are not like web apps that you can crawl, and that you can visually be able to see the types of buttons you can hit and whatnot, is you have to have a specification file. Now, that specification file, you can either retrieve it from a repository as an AppSec engineer, usually contacting the developer asking for it, or it's sitting in a like an API gateway repository where the specs are archived, or using analysis, you would have to reconstruct an API spec in order to be able to test that. And of course, that's both of those two are ways that attackers do that. They either go mine GitHub kinds of things, or they're putting, uh, getting a foothold inside of a proxy in order to be able to watch that traffic and be able to reconstruct what that API spec would be. Right? And that's the case for Invicti as well, is that these are the two components that we need in order to be able to test these systems as well. So we're gonna, before we jump into a demo and stuff like that, let's go over um this some of the ways that we can help you to discover APIs, right? And so we talk about this multi-layered API discovery, and then the second portion of it is reconstructing the specification file when it's needed, right? And so the traditional way and the simplest, well, actually, it's not the simplest way, but the mechanically traditional way is that you need to specify the URL, you need to get the API specification and upload it into the system, and then you can run the scan against it and then discover the vulnerabilities, things like BOLA um, that Jiri was talking about. So that's a very manual process, and it's very effective. But in the context of few, it should be easy to do. But the problem is all. Right? That's the challenge for most organizations, is to be able to get that in comprehensive to the point of all, right? And so what the dev team here, the PM and dev team have done is to create additional mechanism for Invicti to help our AppSec engineers to do this. And one of the newest one that we just introduced, I think this is something that just went to production this week, or was it
Yeah,
last?
yeah, last week. Yeah,
Yeah, yeah. It which
this
is
one last week.
this term that's what you call sensorless API discovery method. Okay, and what that is this is specifically for SPA types of or single page applications that are heavily driven by APIs on the back end, or these are all rendering is done inside the browser. We scan these applications, right? And what we're looking for is what kind of API traffic is being fed to the browser in order to be able to render these applications. So we end up inventorying the API calls inside of there and then reconstructing the API specification. So maybe a little bit later, Jiri will show you like on the dashboard of where these things pop up. But the important thing here is this is exactly what an attacker would do against your website, right? They're going to go to your website, your public website, start crawling that particular application, look for the telemetry information that's from the back end or downstream APIs, and then pivot, right? They'll pivot against the APIs and start attacking the APIs, and which is the most common way that they're going to be able to break through. So we're replicating that behavior, but now we're going to show you the APIs, and the important thing is here is we're reconstructing the API specification by watching this behavior, so that now you got a match of here's an API and here's the specification, so that now you have the ability to be able to test those internet exposed ones that attackers are going to be going after. Now, there's a second portion of the sensorless API discovery also is as we're scanning, we're doing reconnaissance against the site because especially public and third party facing APIs are sort of self-documenting by principle. So we look in the common places, those are the slash API, something, like that. And then we're able to extract that information and present that as API so that you'll be able to, as an AppSec engineer, be able to test those as well. Okay. Um, so now I think that's the important thing here is that sort of out of the box, the experience is great for AppSec engineers because now they've got a shot at APIs without having to engage the rest of the business up to that point, right? And then finding vulnerabilities to take some of the next steps in the layer to get more testing done. So to the next level is the API management integration. So these gateways that especially larger organizations have a little bit more discipline. Is that true, Jerry? Do you think is it just large organizations that are doing the APIM gateways, or is it SMB?
Not necess not necessarily. Sometimes we see it also with SMBs, but it doesn't necessarily mean that it covers everything, right? It's
Mm,
typically that when you're enrolling an API management program or a let's call it like a standardizing compliance program for API development, and then you pick one of these gateways or API management tools, and then you start to roll it out to different development teams. But of course, with large organization, it takes much more time. That's why you cannot only rely on APM integrations.
yeah, it's that discipline, I suppose, right? It's good intent,
Yeah,
but things. Yeah, and that's the problem. We talked about, the loose, right? APIs are loose kind of things. So here the strategy is that we have pre-existing configurations with sort of the industry leading API get API management platforms, right? And so things like Amazon's API Gateway or MuleSoft Exchange is we're gonna you're going to give us permissions to be able to go and I think that's the right word, permissions to be able to integrate with them. And we're going to extract the API specs out of those and give that pairing of the API and the specs so that you can test, increase the test frequency of those particular ones. Right now, you didn't really discover anything because they're pretty well documented at that point, but it did speed these up. So here, the rather than reconstructing, we're retrieving the API spec and that information and then running high resolution scan test against it. Right.
it's a still a lifesaver or a time saver, right? Because if you think of a really large organization, the amount of APIs and the amount of developers who are building them compared to the amount of folks who are part of the AppSec or InfoSec organization, it's so different, which means instead of going after every single individual and say, do you have the API specs? Can you give me the latest and so on? With the API integration, all that is happening automatically. But of course, requires the discipline to be present.
Yeah, absolutely. And then the third one, which is something that you've done a lot of work on in productionizing here, and I see more and more of these integrations coming out, is the network-based API discovery, where we are deploying agents into the front end proxies to watch the traffic coming from the internet or from any portion of the network to identify API calls, and then um, and here especially is that idea of these are shadow APIs that the AppSec team is not aware of, and so now we're seeing what the traffic is, and then by watching that traffic, the API spec is being reconstructed. Right. And here we're tying into sort of those things like F5, the proxies or application delivery controllers, NGINX, Cloudflare, and many others in order to have these pre pre-configured capabilities to at least to speed up the process of discovery. And this, of course, this is a very powerful way to be able to do this. Right. So so those are the layers of API discovery that we can apply, sort of the out of the box with the sensorless discovery, the integrations, and then using traffic analysis in order to be able to do that as well. Right. Now, the second portion of this assurance that these APIs that you're releasing to production is secure is now we need to scan them. Now we need to actually go and look for vulnerabilities, apply a stringent API test with our API DAST scanner here. And so the first area we wanted to talk a little bit about is, okay, so what does that mean to be an API DAST scanner? What are some of these types of things and controls that are being applied? And so Jerry mentioned about that horizontal, of things like BOLA and of being able to move into somebody else. Jerry logs into his permission, but he's able to get to my data, right? And which happens so frequently with APIs, or in the worst cases, to elevate into the vertical direction to be able to escalate into a higher authority kinds of configurations and controls that they have, right? Um, then, then because of sort of the nature of APIs, some other checks that we're doing is looking for sensitive data, specifically around sensitive data like PII or data that is being sent without authentication, which is another big problem with APIs, is sort of that weak authentication practices. Um, and then looking at these web tokens, the Java web tokens, to see, is strong authentication being applied, right? Or are weak credentials being used inside of here? And then, of course, in API, there's API specific types of tests, but APIs are also subject to, because it is HTTP based, they're subject to other types of just web attacks, such as SQL injection, different types of command injection. So there's another whole suite of tests that are run against APIs in addition to those specific ones. And then the OWASP top 10 items obviously are focused on, and those are tested as well. Yuri, is there anything else that we want to talk about this kind of scanning that's being done?
I think we want to talk more about the way how we're trying the scanning of, like, how do we make sure that the scanning is truly comprehensive, right? That it's covering all the all the parts of the API, because one can never be sure that we're testing all the endpoints, all the methods,
Mm.
supplying correct parameters, and so on.
Yeah. Yeah, those are the tricky parts. And so there's a couple of additional methods that we apply into this. One of them is that something that we call stateful API scanning. Um, and here we're watching the traffic, and from like gets versus puts or any other instructions, we're looking at the parameters are coming to us so that we can get context and reuse that kind of structure to make sure that we're not just fuzzing the parameters, but we're using intelligence in order to be able to do that. And this helps to go through business logic better, and that you get a more complete test. And then maybe you could talk a little bit about the authentication side. I guess this is we need to authenticate, and we need to have, I guess we need flexibility in how we authenticate. And maybe you could talk a little bit about this section of it.
Sure, for sure. I mean, it's quite important in the context of those either BOLA, BFLA types of checks, because those actually require to provide two sets of credentials so that we can actually compare, is there a BOLA problem or not, right? Is Dawn able to access my data or not? So in order to achieve that, the customers can set up, or the AppSec team can set up headers, cookies, tokens, different methods, including OAuth 2, to set up an authenticated scan. This also, however, helps us to confirm if there is either weak authentication or if there is any sensitive data leaking without any authorization on that specific API endpoint. So I think with authenticated scanning, you're kind of increasing the comprehensiveness and completeness of the scan, that to cover as much part of the application's API as possible.
Yeah, excellent. But telling is not nearly as good as showing. So, Jerry, I'm going to pass it over to you, and maybe you could walk us through the system and show discovery and show
Yeah,
high efficacy scanning.
would love to. All right, let me see. Okay, you see my screen? Just checking.
There it is. Yep.
Awesome. All right, so as Don mentioned, we're an application security testing platform that is helping AppSec teams discover the web apps and APIs, run comprehensive assessment for all the vulnerabilities using the DAST approach, and of course, help the teams quickly remediate the issues, whether it's done directly by AppSec team or together with dev teams. Now, as a security testing platform, you guys can see on the left-hand menu that there are tools that help with reconnaissance, with the discovery approach, with inventory management, with scanning, with reporting, integrations for the larger organizations, also automating some of the steps that are too mundane or too repetitive, and some of the enterprise level features with SSO, RBAC, audit log, and many more. Now, when customers start with Invicti, they typically onboard a handful of targets. They start with a list of URLs or IP addresses, and Invicti scans those, and as it crawls through the application, it is newly discovering any APIs that the web application is making use of, surfacing them up in the API discovery area. So let me give you an example on how that works. This is the Sensorless API discovery. I have added a web application that the product doesn't know anything about. Let's run a quick crawl on it. As we wait for the scan to finish, let's have a look at the other methods that Don has mentioned. I have pre-configured an APIM integration with MuleSoft. As you can see, sync has completed. We're running a regular sync with MuleSoft repository of APIs, and all of them land in the API discovery module. This is where you can examine the different methods, operations, and of course, turn them into something that can be scanned, or we call a target. Now, customers who have the inventory of APIs in APIM can set up this simple integration with the likes of Azure APIM, AWS API Gateway, MuleSoft, and others. And this is a super fast way to onboard any APIs that are known and push them quickly through the process of scanning for known vulnerabilities. Let's take a look at this specific API, which I already have in my catalog, and run a scan on this. I have not yet added an authorization on it for BOLA and BFLA, so let me just do that real quick. Let's call this user an admin. I'm going to quickly add his tokens. then first user, and then a second user. The reason why I'm adding admin and 2 standard users is to ensure that we can test for both the vertical, so user versus admin, as well as the horizontal, 2 users who should be able to see each other's data. Once we save the credentials, we can kick off the scan, and I'm going to just focus on the OWASP top 10 API profile to make sure that we focus on the biggest risk here. These 3 users, and as I mentioned, 2 is minimum because we want to test either vertical or horizontal, ideally both. The scan is going to take about 3 to 4 minutes to complete. That's the efficiency of running an API scan. You don't have to crawl the application, and typically APIs are very responsive so that you get a very quick response back. Meanwhile, I'm happy to take any questions. Please shoot them into the Q&A. Now, while the web application scans are running, Invicti also finds automatically, without any intervention, any APIs that the web applications are using and that are hosted on the target. You can have a look if the discovery already has anything. Okay, looks like we have those 2 scans still running. So let's take a look. All right. Well, we can already see that scanning was started. We have done some introspection of the GraphQL, which means we are seeing also GraphQL endpoints that the application is making use of and enumerating them. Some of the organizations consider even enabled introspection of GraphQL to be a problem. So this is a good indicator for us to check or cross-check or confirm if this is a risk or not for the organization. And then after the scan finishes, we'll be able to instantly see the different types of APIs that have been discovered. So let's keep the scans running. We can already see that the OWASP top 10 scan on a vulnerable API is finding stuff. Let's quickly cross-check. Yep, there we have it, horizontal BFLA. We have some sensitive data available or accessible without authentication. There's more vulnerabilities that will be coming in, so let's leave that to work. And the last component for running discovery, as Don has mentioned, is leveraging a network traffic analysis. To give you a quick idea, I have set up a NGINX, which illustrates the edge of my application, and a sample application that is providing me with some additional data when I'm going to poke into it with a set of API calls. So to do that, I'm just going to run these calls. You can see some posts, deletes, puts, and so on. Some of them will succeed, some of them will fail. But as those calls are being made, suddenly the application is reaching out to the NGINX, which I'm observing. We can have a look here that NGINX is already getting some requests in. And at the same time, we're observing the traffic. We're seeing that something's going on, some traffic is ending up in NGINX, and our reconstruction is capturing that traffic. And shortly afterwards, it's going to go through the findings and say, okay, well, this is an API call, this is not an API call, successful, failed, and so on, and triage which findings should be pushed upstream into the Invicti platform. Let's hit refresh and see where we are. Okay, might take a few minutes. Shortly, we will see that the API specs are coming in. All right, going back to the scans, I think, yep, there we go. So the scan of broken crystals, or crawl of the broken crystals to be more precise, is completed. We can see that there have been some specs discovered. We have also reconstructed some APIs from just crawling the application. So let's take a look at the discovery. All right, so in here, we can see that broken crystals, there are some endpoints that have been found and reported. And then we've also found a physical spec file that was hosted on the target. We can instantly click on turning it into a target and running a scan against it. Now, meanwhile, I can see that the network traffic analysis from my NGINX has already done its job. So all those puts, deletes, requests, gets, and so on have made it through the NGINX, and NTA has successfully captured those. So again, I can turn this into a scannable target and run a test against that application API operations. And last but not least, we should be seeing, okay, cool. We have the vulnerable API as a demo application. Great. We've also found some API specs on it, but the main point of this demo is to show you how Invicti is actually detecting and reporting the different types of vulnerabilities, whether it's the horizontal bolas on different endpoints, vertical bolas. In this case, I believe that some user was able to, yep, there we go. So one user was able to actually access something that only admin should have access to. Weak secrets. So if the teams are not securing their secrets properly with the correct algorithms, we get a sample, and we explain there is a high risk to do that, and many more medium vulnerabilities, whether it's sensitive data exposure or some additional more generic or lower value problems. What's interesting here is that not only these API specific vulnerabilities are found, but even things like SSRF, which is not isolated to APIs only. So customers can get all the necessary details on what it is, how to remediate it, where it was found in order to work with the development teams. Once we finish the work, we can have a look at the API insights, because this is truly the oversight for AppSec, for them to figure out, are there any APIs that I should think about? Because imagine that either the APIM or the network traffic analysis or Sensorless, all of them, once set up, are running completely in autonomous fashion. So new APIs can be discovered as teams build them, right? There are some APIs that are already in catalog. There are some APIs which are vulnerable, and there are APIs that are most recently found. So these are showing this widget is showing the findings. I can go and explore the list and either act on them or hide them or restrict them from being tested, and so on and so on and so forth. Excuse me.
Fantastic. I love that you kind of had that dashboard cleared, and now we can see just that last cycle that you just did with all of these on. That really helps.
Yeah.
Perfect. All right. Um, so great. All right. So we went through the demo. As we sort of close the webinar, Jerry, I wanted, maybe you could talk a little bit about this website and the objectives that PM has
Yeah,
for this.
definitely. Well, as a product team or member of product team, we're highly interested in what our customers or prospects or the whole world thinks about the problems that AppSec teams have. That's why our roadmap is publicly available. There are items which are already planned. There are items which are under consideration, for which we're looking either validation from the market, like, is this really a big problem that everybody wants to, everybody needs that? And by doing so, you can leave us your contact details, and then we can follow up with you and have a more deep or thorough discussion about what exactly that means to you and your business. Is it about efficiency of AppSec? Is it about um, getting better reconnaissance or better thoroughness of a scan? Or is it about something completely different, like consolidating or simplifying the work of an AppSec, because you're getting the sprawl of different tools from SAST, DAST, IAST, and you just need a single way how you can look at the findings and assess the risk in the end. So for those of you who are our dear customers, or who are planning to become our customers, we highly encourage you to take a look at our public roadmap. We would love to get your feedback and leave us a note. If there are ideas, we'd love to hear them. And yeah, that's what we have. What do we have
Yeah.
this for?
And there's a number of items up already loaded up there that are around API and around this API discovery and testing. So we
Oh,
invite you
100%.
to participate with us, share your ideas, and let's see how we can help you with these things. Okay, so we're gonna move over to Q&A here in the very last portion of it. We were hoping to try to limit this to about 45 minutes, so we'll just take a couple of questions. So if you have some, please go ahead and put it into the Q&A window. So here's a first question. Says, how do you prioritize discovered API vulnerabilities, and can we customize risk scoring based on our business context?
Great question. So typically, when you prioritize, the way you prioritize discovered API vulnerabilities is based on their rating. Now, Invicti provides an out-of-box way to rate the different vulnerabilities that you can even customize in our new platform. So if you decide that, for instance, sensitive data exposure is not a medium vulnerability to you and your organization because of compliance reasons, you can bump that severity higher than it is, and it's going to be respected by every scan that is found.
Okay, perfect, perfect. We'll do one more question, and then
Okay.
this one says, what's the performance or operational overhead of using NTA-based discovery across things like NGINX and Cloudflare?
Mhm. Simply put, um, NTA itself is running as a sidecar to the application traffic flow. So we're not in line, right? We're running the analysis outside of the actual traffic. That means that there is minimal overhead, which is put on the edges that we integrate with tools like NGINX, Cloudflare, or F5, because these natively have a way to look into the traffic to see the request responses that we're using for the discovery of APIs from traffic.
Okay. Well, uh, okay. All right. Well, you know what? We wanted to stop right at 45 minutes, and we're at that time. Jiri, thank you so much for joining me on this
Thank you
webinar.
for running the show, Don.
I hope it was useful for the for our audience, and feel free to reach out to us anytime. And thank you so much for joining us.
Thanks, everyone.
Bye.